Okay guys, welcome to the 3.3 video for Colebank and Mandsager. Today we are going to be talking about determinants and inverses. So the objectives for today are I can find the determinant of a 2x2 matrix by hand, and I can find the inverse of a 2x2 matrix by hand. So here's the vocabulary. First off, we're starting with the word determinant. That is a value that can be found from the elements of a square matrix or from elements of square matrices that determines whether an inverse of the matrix exists. And then we also have inverse matrix. This is a matrix that can be found and used as an alternative to matrix division, which is typically undefined. So first we're going to talk about finding the determinant of a 2x2. And honestly, when you're finding the determinant of a 2x2, you are just following a formula for the most part. So the properties of a determinant. The determinant tells you whether the inverse of a matrix exists. If the determinant equals 0, then the inverse of the matrix cannot be found. So we're always going to be finding a determinant first. The determinant tells us whether or not we can find the inverse. And if we can find the inverse, then the determinant is also part of the inverse, and we're going to talk about that. So here's some just notation things. You might be told to find DET and then a capital A, so that would be the determinant of matrix A. There's also determinant notation. It looks a lot like absolute values, but if you have those two bars, that means determinant, and sometimes like on worksheets, you'll just have two bars around a matrix, and they're trying to tell you that they want you to find the determinant. And then the way you find the determinant is you find AD minus BC as if A, B, C, D were in the matrix in that order. Okay, so you're going to look at the different elements in the 2x2 matrix, and then you're going to multiply the two numbers in the A and D position together, and then subtract B times C. So here's how that looks, and I did keep all of that determinant stuff at the top. So it says, find the determinant of the following matrices. So again, this is a 2x2 matrix. We can kind of go through and say, okay, A, B, C, D. And then the way you're going to find the determinant is you're going to do A times D minus B times C. So I'd have -1 times 4 minus -1 times 1, and I guess I'll put everything in parentheses just to keep it organized. And then you're going to simplify until you get a number, I guess. So -4 plus 1 would give me -3. So that would be the determinant of that 2x2 matrix. Again, since that is not equal to 0, an inverse exists. And if I wanted to find the inverse of that matrix, I could once you've seen the second part of this lesson. But again, you want to remember the determinant determines whether an inverse exists. If the determinant is a non-zero number, you can find the inverse. If the determinant is 0, then you cannot find the inverse. Then we can move on to B. So on B, I'm given slightly different notation. This just has those bars, so this is saying, hey, find the determinant. And that is important just because sometimes I wouldn't type it on a test, but again, for the most part, I'm going to say in words to find the determinant. But you can also have that notation. Again, the only difference is it doesn't have the little top and bottom parts to the matrices, or to the matrix, I guess, in general. But that is, it looks like absolute values, so it's determinant telling you to find the determinant. So again, you need to find what's in the A, B, C, and D position, and then you're going to find A times D minus B times C. So I'm going to have 8 times 9 minus -6 times -10. Oops, sorry, then I can simplify. So 8 times 9 is 72 minus, and those would give me +60, so -60. So the determinant would be 12. So again, since the determinant is not 0, an inverse exists, which is the reason, or one of the reasons why we find determinants in the first place. So my suggestion would be to try to do C and D on your own, find the determinant of the following matrices. So go ahead and pause the video. Now hopefully you're ready to check. So AD minus BC would be 0 times -2 minus -4 times -6. That's 0 minus 24. So your determinant would be -24 on that one. Again, it's non-zero, so an inverse exists for that matrix. That's in matrix notation. And then I could also give you determinant notation. Hopefully you did D already. So you're going to do A times D minus B times C. So -5 times 2 minus 3 times 4. -10 minus 12 gives you -22. So again, it's non-zero. An inverse exists if we wanted to find one. Now that I've mentioned an inverse existing so much, we're going to do example E and then talk about the inverse. So I forgot this example was here. My bad. We are told to find the two determinants based on that determinant notation. And this is just another way that I could have you practice determinants by doing the sum of two different determinants. So the way that I would write this one out is I would have the determinant of my first matrix, the determinant of my second matrix, and then we'll add them up at the end. So again, the determinant comes from what's in the different positions. So I have 1 times 4 minus 2 times 3, and then I'm going to have 5 times 6 minus 2 times -2. So when I simplify those, I have 4 minus 6, and then I'm going to add that quantity to 30 plus 4. So it looks like -2 plus 34, so positive 32. Okay, so now we're going to move on to inverses. So now that we feel good about finding determinants, we're going to use them to find the inverse of a 2x2 matrix by hand. So why do we need matrix inverses? Well, since we do not have a way of performing matrix division, we must instead use inverses to get the same result. So we've talked about matrix addition, subtraction, scalar multiplication, and regular multiplication. But the operation of division is actually not defined for matrices. So we have to use inverses as a bit of a workaround. And we actually do this with numbers too. So just as with integers, multiplying by an inverse gives the same result as division through a slightly different process. So here's what it looks like with integers. Typically, we just do division. We'd say 6 divided by 3 equals 2, and that's true. However, if you can't divide by 3, an alternate way of getting the same result is to multiply by the inverse of 3. And that's what that little -1 means. It means inverse. And the inverse of 3 is 1/3. So if I multiplied 6 by 1/3, I would get the same result. So that's kind of what we're going to do with matrices, okay? If you started out with a matrix, so say you had a matrix like 2, 1, 3, 4, and you wanted to divide it by a matrix 1, 2, 3, 4, you can't do that. That does not exist. It's undefined, okay? Or actually, it does exist, just not through that operation. But I guess we would just say undefined. To be honest, people don't try because they know division is undefined and not explained with matrices. You can't do it. Instead, you multiply by the inverse. So basically, the thinking is, okay, well, if you take 2, 1, 3, 4, and instead you multiply it by the inverse of this matrix, sorry, that should be a 3. If you multiplied it by the inverse, you would then be able to get a matrix that would have the same value as if you had divided it. So we're going to talk about how to find that inverse matrix, and then we will be able to effectively do matrix division if you multiplied by the inverse. So here's how you find the inverse, and it's a formula. If you have a matrix and you're finding the inverse of it, you're going to have a scalar in front, that's 1 over the determinant, and then you're going to move some stuff around in your matrix, and you'll simplify this. So if you look, if we look at the difference between the original matrix and then the one that's part of the inverse formula, notice A and D have swapped spots, and then B and C are opposite signs to what they originally were. So the first thing we're going to do when we're finding an inverse is we are going to find 1 over the determinant, and then we're going to multiply that by the matrix once we've moved the A's, B's around, and once we have found the opposite signs for B and C. It sounds like a lot, but it's actually not a super hard process. Now, the other thing that's nice is I did leave this image on every page, so you're going to be able to refer back to it. If you have to find inverses and determinants, though, on a test, we would expect you to have this memorized, but the other thing is we're going to show you how to find these in the calculator later on. So, find the inverse of the following matrix. So here's what I'm going to do. The inverse, I can just put to the negative first, and then that means we're finding the inverse. I need to do 1 over the determinant, so 1 over the determinant. Well, if these are A, B, C, and D, it'll be 1 over negative 3 times negative 1 minus 1 times 9. So that's the determinant, and we'll simplify that in a second. And then we're going to multiply it by a version of my original matrix, but I have to move some stuff around. So I'm going to take A and D and swap them. So instead of starting with negative 3, I'll have negative 1, and then negative 3 will be my last element. And then B and C stay in the same spot, but they're going to be opposite. So my 2 by 2 is now going to have elements of negative 1, negative 1, negative 9, and negative 3. Then it's just a matter of simplifying the determinant and finding out what you would get after the scalar multiplication. So if I go through and simplify that determinant, I have 1 over 3 minus 9, and I'm going to multiply that by that matrix that I already moved everything around in. So 1 over negative 6 times all of that stuff. And then you do want to go ahead and do the scalar multiplication. So you're going to take negative 1/6 and multiply it by negative 1, negative 1, negative 9, and negative 3. So by the time you do that and you reduce, you're going to get an inverse that is 1/6, 1/6, 3/2, 3/2, and 1/2. So that would be the inverse of the matrix that we started with. So you could then multiply this by another matrix, and you would effectively be doing division. Okay, we're going to do another example, and then you're going to try the last two on your own. So first, I want to show that I'm finding the inverse, so I'm just going to put that little negative 1 in the corner, and then I'm going to be able to set up 1 over the determinant. It might be helpful for you to label A, B, C, and D, or you might even want to write out like A equals, B equals, C equals, and D equals. But again, we're just kind of referring to this formula up here. So I have 1 over the determinant, which is going to be negative 3 times negative 3 minus negative 3 times negative 4. And then I'm going to multiply that by this matrix that we manipulate. So A and D switch spots, doesn't matter in this one. And then B and C are going to have opposite signs from what they started. So 3 and positive 4. Then we simplify. So I get 1 over 9 minus 12 times that matrix that we manipulated around. Then we can simplify the determinant, so it would be 1 over negative 3. And then you're going to do scalar multiplication with that negative 1/3. So your final matrix, you'd have negative 3 times negative 1/3, which would give you positive 1. 3 times negative 1/3, which would give you negative 1. 4 times negative 1/3, so negative 4/3. And negative 1/3 times negative 3, which would give you another positive 1. So that would be the final inverse of the original matrix. 1, negative 1, negative 4/3, 1. Two more examples. So let's do H as a class and then pause on the last one and try it on your own. So again, we're just following the formula for the inverse. So I'm going to take this original matrix, put it to the negative first, which tells me that I'm finding the inverse. 1 over the determinant, so I have A, B, C, and D. I have negative 4 times negative 1 minus 0 times negative 8. And I multiply that by the new matrix, which is everything swapped around. So A and D switch spots, negative 1, negative 4. B and C have different signs. So 0 is not going to change, but negative 8 is going to go to positive 8 before I start simplifying. So I can simplify. I have 1 over 4 plus A times that matrix that we moved all around. So that's 1 over 12 times this matrix that we moved around. And then you're going to go through, and you might need to do it in your calculator, but most of you could probably do it in your head. Do the multiplication and simplify. So your final answer would be negative 1 over 12, 0. 8 over 12 would reduce to 2/3. And then negative 4 over 12 would be negative 1/3 as your final inverse. All right. Last up, I want you to try this one on your own, and then I will go through and show you the answer. So find the inverse by finding the determinant, moving stuff around. All right, so as you worked your way through this problem, you would have ended up with 1 over 10 times 4, 1, 2, 3. So the final inverse in that example would be 2/5, 1 over 10, 1 over 5, and 3 over 10. Last up, take a look at the objective recap. I can find the determinant of a 2x2 matrix by hand, and I can find the inverse of a 2x2 matrix by hand. If you feel like you can do those, then move on to your homework. See you later.